Question 270. You have two Google Cloud projects, Project A with vpc-a 10.0.0.0/16 and Project B with vpc-b 10.8.0.0/16. Your front-end application resides in vpc-a and the backend API services are deployed in vpc-b. You need to efficiently and cost-effectively enable communication between these Google Cloud projects. You also want to follow Google recommended practices. What should you do? A. Create an OpenVPN connection between vpc-a and vpc-b. B. Create VPC network peering between vpc-a and vpc-b. C. Configure a cloud router in vpc-a and another cloud router in vpc-b. D. Configure a cloud interconnect connection between vpc-a and vpc-b. The correct answer is B. Create VPC network peering between vpc-a and vpc-b. Explanation 1. Why this is the best option. VPC network peering is the most cost-effective and efficient solution for enabling communication between two VPCs in different Google Cloud projects. It allows private, direct communication between resources in different VPCs within the same region or across different regions, without the need for external IP addresses. Peering provides a simple, low-latency connection between the VPCs and is managed within Google Cloud, making it highly scalable and reliable. VPC peering is Google recommended for inter-project communication when both VPCs use private IP ranges, which fits your use case perfectly. 2. How to set this up. To enable peering between vpc-a and vpc-b, you can use the Google Cloud Console or the G-Cloud CLI to create a peering connection. After setting up the peering, you can configure the necessary firewall rules to allow the desired traffic between the VPCs. Why not the other options? A. Create an OpenVPN connection between vpc-a and vpc-b. OpenVPN is a solution for creating VPN connections, typically used when connecting a Google Cloud VPC to an on-premises network or when you need encrypted connections over the Internet. It is not the most efficient or cost-effective option for communication between two Google Cloud VPCs. OpenVPN would involve additional setup and overhead, such as managing VPN gateways, client configurations, and encryption keys, which is more complex than VPC peering. C. Configure a cloud router in vpc-a and another cloud router in vpc-b. A cloud router is used for dynamic route propagation in scenarios involving cloud interconnect or VPN connections, often in hybrid cloud setups or when connecting VPCs with complex routing requirements. Cloud router is typically not needed for simple inter-VPC communication in Google Cloud within the same region. It is more relevant in advanced networking scenarios involving cloud VPN or cloud interconnect. D. Configure a cloud interconnect connection between vpc-a and vpc-b. Cloud interconnect is a solution used to establish a dedicated, high-throughput, low-latency connection between Google Cloud and on-premises networks or other cloud providers. For communication between two Google Cloud VPCs, cloud interconnect is unnecessary, as it is designed for different use cases. VPC peering provides a much more straightforward and cost-effective solution. Conclusion. VPC network peering is the optimal solution for enabling communication between two Google Cloud VPCs in different projects, following Google recommended best practices. It is simple to implement, cost-effective, and requires minimal configuration.